Hiya, I'm Emma, and I'm from Sheffield, Hallam University. Oh, there I am. I am very definitely a designer and a product developer. I take a very analogue approach in this kind of digital futures room, which is a bit scary. I have a background in industry, worked in industry for about 10 years, and then went to M-ADE to do my PhD. Specialised a bit in kind of convective heat transfer through clothing systems, and then I worked on the Sportswear undergraduate pathway there, and then moved to Sheffield, Hallam about 3 years ago, and co-wrote the course, the M-ADE Design for Performance Sports, which is now up and running, and I'm leading. Okay, so I'm going to talk to you today about user-centred design. At Sheffield, Hallam University, we're really keen on the Design Council's Double Diamond model, which is basically a visualisation of the design and innovation process, but with users very centric to that. So you have these two loops. It starts with discovering and understanding rather than assuming what the problem is. Defining by using kind of very user-centric research methods, secondary data to really define what the problem is. So often we'll have clients that come in and want us to solve a problem, but we really kind of take time to understand what that problem is and redefine it if we need to. And then we kind of develop, we use lateral thinking to think about what methods might be best to answer those solutions, to create solutions to those problems, and then we use small-scale prototyping to test and refine that. But my background is very much in qualitative research and the importance of users in the design process. And so I prefer to see what we do as a pyramid, with the importance of understanding user needs right at the bottom, so that your design solutions don't topple over, and really using that to drive everything you do through the design process. I'm interested in people. So people drive. As I've gone kind of through my career, I've realised that what really interests me is people and what people do. And I found this model when I was writing my PhD. It's Lam and Kalal. It's quite old now. It's been revisited lots of times, but it really brings together these ideas that, yes, products need to function. They need to do, they need to answer those kind of really gnarly design problems, but you also have to understand what that garment means for people in those cultures and performing in those cultures, and what that needs to look like to achieve that. And why do people do silly things like that? Why do they go out in December and do duathlons in the mud and the rain? And kind of what I think might be important in terms of what my clothing should look like is different to what my brother might think, or my husband. So I'm really interested in this body-product interface and what happens when those things come together. So I'm interested in story-driven design, so really kind of these really rich stories about why people do what they do. So I'm going to talk to you today about kind of an applied project that I worked on with a guy that was going off to do the 6633 Arctic Ultra. So we're looking at exploring the design environment, the real base of this problem. So he sent me this picture. He's like, wow, that's amazing. So basically he tried to do this Arctic Ultra Marathon. It's in the Yukon, it's in March, average temperatures are -15 degrees, and then you've got the wind on top of that, so you can take another 6 degrees off that. You're working really hard, you're sweating, and that moisture is evaporating off your face and then condensing on the cold layer of your goggles. And so then it freezes, and you can't see where you're going, and it's dripping, the condensation is warm, it warms the materials that you're wearing next to your face, they're getting wet, then they're freezing, it's all dripping down, it's horrible. So what do you do in that situation where you can't see what you're doing? You take your goggles off, and then the wind's hitting you in the face, you're at risk from getting frostbite. You've got to take your mittens off to clean your goggles, so then your hands are at risk, your hands are getting colder and colder, and then you can't put your it's a struggle to get your gloves back on, and then you get your goggles back, seated back on your face. So basically, he fell over, hurt himself, and had to pull out of the race. So then he's coming back 3 years later, he wants to have another go and he wants to know whether we can do anything about this. Okay. We basically had a look at, or we did some kind of photo elicitation kind of interviews. We were having a look at what his experiences were, and then we looked at what other products he'd been using, what was on the market, and kind of what the problems with those were. And we used this really powerful tool called the House of Quality, which basically uses that information and uses thematic analysis to define user needs and ranking them in order of importance. And it's really important because then you've got a pathway backwards. You can read his experiences in context, but then you can drive it forward to say, okay, so this is what he's saying, this is what he needs, so what would a specification for this piece of kit be? And then you can use that further up your pyramid to then, as you're refining and testing, to test against those specifications. So you're really rooting what you're doing in user needs in a very systematic way. You can rank them in order of importance, and you can also use it later on if you need to trade off on anything. So now we're thinking, what solutions can we do to kind of get around this problem? So I was working at MMU at the time. I was working with Dr. Andy Moss and Dr. Keith Winwood, and Andy's an exercise scientist, so he was like, we use these masks where we're measuring expired air, so they seal really closely against your face. Maybe the problem is that the warm air's venting up these little air channels here into your goggles and it's condensing on goggles. So can we have like this really sealed mask? And Keith is a facial reconstruction scientist. He's like, why can't we glue some prosthetic skin onto his face before he leaves? And then he'll be fine. He never has to take his, anything off and everything will be great. And I was interested in kind of fur at the time and about how Eskimos wear baffles around their hoods, and that does clever things to the laminar flow of air across your face and creates insulation and deflects the wind. So we had and we were doing all of this with the client, and he'd got his own ideas. So it's a very collaborative process and a bit bonkers. But in a serious way, all the time we're relating back to these specifications and thinking about that wearer product interface. So it's going to be, he wanted to go down a very much more traditional route. He didn't want to look like a cyborg walking across the Arctic in March. He wanted to look like everybody else. So we wanted a kind of traditional looking mask. So we're starting to look at materials that are super breathable, that might be hydrophobic or hydrophilic, depending on what they're doing, that they're still insulating, that they're protecting you from the wind, protecting you from the snow, and kind of what does the construction of this mask look like? Is it going to be super flat kind of cover sealing or welding technology, or is it really just lock stitching? And how are we going to finish it? How are we going to make it look okay for him? So what we come up with in the end is this kind of made-to-measure mask. Oh, by the way, Keith Winwood, at the time, we wanted to head scan him so that we had a scan of his head so it could be really made-to-measure. But we didn't have a head scanner at MMU. I don't know whether do you have one now?
We've got a body scanner.
Oh, right. Well, we couldn't head scan and we couldn't 3D his head. So Keith cast his face for me. So the dead body shape is like basically my client's head, which we then use with these goggles to create this made-to-measure mask. And we basically tested this out in the climate control chamber at MMU. We got it down to -20, which, if you're interested, is the coldest it will go, and the treadmill will still work. So we wanted him to be kind of doing the same kind of load that he would be doing and kind of doing the same kind of exercise. And what we found was he didn't like the openings for his nose. Whether or not the wind could get in there, it made him psychologically worried that he would be able to get frostbite on the end of his nose. And also it was catching on the sides, so it was just not a runner. And then he liked the ones where his full face was covered, but and then he just wanted this massive seam on the front because he could grab it with his gloves on and just pull it off. So that's what we went with. So this is him just before he's going. He's got this tailored mask that covers all the exposed skin on his face and his nose. It's using an insulating polyester spacer mesh, so it's got a mesh on the front and the reverse, and then these vertical filaments in between. So it's super breathable, but it's also creating this dead air in that fabric, so insulating. It's got nylon ripstop over the top. It's like really densely woven. It's not coated, but it stops the wind. It's got these magnetic snaps, so it's like really audible clip when it goes on, so he knows it's there. Just a really basic superimposed lock stitch construction, super lightweight and actually really compressible. He had about 3, he just screwed them up and put them in every pocket, and it was fine. So we've got this mask, and he's going anyway, he's going to wear it, and we want him to be safe, so we sent him off with, he took his tried and tested stuff. They wouldn't let me go with him. I thought it was a really good opportunity for some participant observation here, but no. So he went off, and we were thinking, how can we test this and get a little bit of data where it's not going to affect, he's got to be able to do it safely, he's got to be able to do whatever he does, but how can I collect a bit of data around that? So he walked with a little data logger in the pocket of his He's got a little sledge, and he's got a bag on the top, and he's carrying everything in this bag on this sledge, and it was just in an outside pocket. So he carried that. He's got a tracker on for the race, so he had his tracker on, and so I can log where he is in the country. So I logged that data against weather station data, so I knew kind of what was going on. And then he's taking selfies of himself on the phone. And I can track that, so I got the photo logs, and I'm tracking that against this tracking logger. So on the map on the left-hand side, you can see his route across the Europe, north towards across the Arctic Circle. So at the beginning, the photographs are all, yay, it's sunny, we're on our way. And then in the middle, they're like very contextual, like, oh, this is the road, and then I've been walking for miles and it's dark. And then right at the end, the weather got really bad. And this is where it's quite interesting. So on the 3rd day, this is the data from the 3rd day. The solid orange and grey lines, the max and min temperatures from the weather station at the start of the walk, Rock River. And then the yellow and the blue thin lines are, so the yellow line is the air temperature, the blue line is the wind chill at Fort McPherson, which is where he's going to, and the thick blue line is our data logger. And kind of what it showed us was that the data logger was working. It's followed the same kind of pattern as the weather, that he was doing this walk in about minus 15 on average, so it's about the average temperature that you would expect in the Yukon at that time. But obviously there's wind chill, so he's actually, the actual real temperature on his face is another 6 degrees colder than that. And it works. You can see if we compare this little photo to the photo before, he can see where he's going. He doesn't fall over. Okay? And his feedback when he finished was that he felt really safe within that environment. It was like it created a little cocoon around his face that he was breathing in, and it was a really nice microclimate in there. So he didn't feel uncomfortable, he didn't feel wet, the materials around his face aren't wet, he didn't get frostbite. And this audible clicks were really important to him because it gave him real confidence. Like, try to imagine you're in this tiny little one-man tent in the middle of nowhere, it's pitch black, the wind's blowing, and you're trying to get dressed in all your layers to go back out to walk another 6 hours across the Arctic. He snaps it on, puts his goggles on, and he's happy. So there you go. That's kind of the story of this guy, kind of an applied idea of what happened, of how my work goes. So now, kind of, where are we with that double diamond now? So the Design Council has expanded the double diamond to produce a framework that supports designers and design engineers to improve design standards, but that promote sustainable development. So as well as divergent and convergent thinking, the double diamond process encourage us to consider that micro detail, that really important rich story detail that we're getting from our users, but in a macro kind of way, so that we're thinking about the impact of what we're doing on the environment, and encourage us to understand the root causes and issues and disrupt problems to make change, and to create relationships and connections that drive storytelling that are grounded in core values. And that's very much now where my work is heading, and I don't have time to tell you about all of that, but thank you very much.
Thank you, Emma, for your presentation. That was really interesting. Does anyone have any questions? You all have questions. Ah, lovely, you do. Perfect. Please do.
With an easy one, I think. Have you had any developments on this? Because I saw the day was 2018, and yeah.
No, so I left Manchester Met quite soon after that. So this has become very much kind of a case study for research-led teaching. And yeah, I went to Sheffield Hallam because they're very practice-based university, and they're kind of very applied practice, and that's kind of what I've been trying to develop in my work. So now I'm working very much more kind of applying this with clients, which is where I'm going at the moment, particularly down the sustainable route. But I can't talk about it at the moment.
It's a nice case study.
Sorry. I'll come back in a year and tell you about that.
Thank you. Does anyone else have any questions they want to ask Emma?
Maybe another one. I was thinking that the story is very incredible because of the way it was all frozen and you couldn't see anything and horrible. But I was wondering, before him or with him in the race, no one else had that same problem, or how did they, cope with that?
So there's things that are there's loads of things on the market. The thing that most people want to use is a buff because it's easy, it's compressible, it's thin. Shove it again. You can have 3 in your pocket. And what happens is you can breathe through. It's really breathable. It creates that kind of nice microclimate around your face. But the condensation gets into the material. It freezes and it feels horrible. So they move it around. So this frozen bit moves around your head, but it dries as it gets to the back and starts moving around the front. So that's kind of what happens. There's some really interesting products on the market. There's one like a Darth Vader mask. It's really, you look really cool when you use it. But unfortunately, it's got like a little plastic valve in it, and he accidentally swallowed his. So, that works for a bit. So yeah, and people get frostbite.
Yeah.
That's the reality. They do it because they love it, because people are mad. Back to that, why do people do what they do? But yeah.
Amazing.
Thank you for that, Emma. That was a really fascinating presentation, so thank you very much.
Thank you. Thanks, guys.